Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 10th, 2026, just 3 days ago. It introduces Aletheia, a math research agent that achieved 95% accuracy on advanced proof benchmarks and even generated a full research paper without human intervention. The paper is titled, Towards Autonomous Mathematics Research, and as we'll see later, the system's ability to solve open problems autonomously is really impressive. To organize these findings, Table 1 proposes a standard taxonomy for AI mathematics, much like the levels used for self-driving cars. The columns across the top categorize the degree of autonomy, ranging from primarily human work to essentially autonomous generation. The rows then rank mathematical novelty, starting at level 0 for negligible results and rising to level 4 for landmark breakthroughs. You can see the fully autonomous eigenweights paper located at level 2, meaning it qualifies as publishable research. However, the solved Erdos problems appear in the upper right at lower novelty levels, which suggests that while the agent is autonomous, its independent discoveries are not yet considered major mathematical advances. So, to reach those levels of autonomy, Figure 1 presents the system architecture, called Aletheia. Powered by Gemini DeepThink, the workflow starts on the left, where a generator creates a candidate solution for a given problem. Next, a verifier checks the work. If the solution is critically flawed, the red arrow shows how it loops back to the generator to try again. But if only minor adjustments are required, the reviser agent steps in to polish the attempt. This cycle repeats until the verification succeeds, yielding the final output. Alright, Figure 2 demonstrates the performance impact of these improvements. On the left, Panel A compares the models on Olympiad-level problems, showing that the new January 2026 model in blue significantly outperforms the older July version in orange. Notably, it achieves similar accuracy with roughly 100 times less compute. The red star marks the full Aletheia system, which jumps even higher to about 95% accuracy. On the right, Panel B shows that this advantage holds for PhD-level exercises too, while the base model improves with scale. Aletheia surpasses it, pushing the score close to 50%. While moving from benchmarks to real discovery, Table 2 categorizes the specific contributions Aletheia made to the Erdos conjectures. The first row, autonomous resolution, highlights the most exciting outcome. For problems 652 and 1051, the agent produced a genuinely novel solution. However, the lower rows, like independent rediscovery, show that often the model derived a correct proof, only for humans to find that the answer already existed in obscure papers. This distinction is crucial because it separates true mathematical breakthroughs from simply duplicating past work. So, while the previous table categorized the types of success, Table 5 reveals the raw success rates on 200 Erdos problem candidates. The results are humbling. The first row shows that 137 attempts, or about 69%, were fundamentally flawed. Even more telling is the gap between the next two rows. While 31.5% of solutions were technically correct, meaning they satisfied the literal text, only 6.5% were meaningfully correct. This massive drop-off happens because the model often finds trivial loopholes or misinterprets the mathematical intent, which counts as a technical win but a meaningful failure. To ensure transparency regarding these contributions, the paper introduces human-AI interaction cards, which log exactly where the model stops and the researcher begins. The top card tracks the FANG 26 paper. You can see the human acts largely as a prompter here, asking for computations on type A, C, and D groups, while Aletheia returns fully correct derivations autonomously using advanced tools like Aletheia bot localization. In contrast, the bottom card for LeCO 26 illustrates a collaborative loop. Here, the human queries a challenging extension, and Aletheia responds with a high-level proof outline, identifying key concepts like dual sets. Crucially, the final step shows the human researcher taking that outline and refining the details to complete the proof. Wrapping up, two takeaways stand out. First, AI has successfully transitioned from competition math to generating novel, publishable research. Second, despite this autonomy, the low rate of meaningful solutions suggests that human intuition remains vital for guiding these discoveries. This marks a shift toward AI as a research partner. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.